going to just actually start the live broadcast as well. And that is on. So right now we are live on Teams. I see people have joined. We are live on YouTube, where I didn't announce that we would live stream because I didn't know that I would get the technology to work. So I'll just look through the contents of it and see that we don't have any echo effects on the audio and so on, and if that works. And for the rest of the season, we will do live streaming to YouTube again. First SQL Friday of the season, which is season 9, I think. It's SQL Friday number 146, and we have Haripriya Naidu. Did I pronounce that correctly?
Yes, you're right.
Oh yeah, first attempt, cool. So TempDB Contention, I saw Haripriya present on New Stars of Data last time it ran, and I really liked it, so I took the liberty of contacting Haripriya and asked her to send in an abstract for the upcoming season of SQL Friday, and here we are. So welcome to SQL Friday, and apart from like the standard things, if anyone has questions, type them in the chat and I will relay them to Haripriya as we go along. Do you want me to interrupt for questions, or will you stop for questions at
Yeah, I will be making pauses in between for questions, and I can take questions at that time.
Okay, cool. Then I'll monitor the chat for you, so you can concentrate on the presentation, and the stage is yours. Glad to have you here.
Thanks. Yeah, thanks, Magnus. Hello, everyone. Thanks for joining. Today, I will be discussing about one of the most common issues in SQL Server, and that is TempDB contention. This is one of those performance issues I've learned the hard way in my earlier years as a database administrator. And I want to make sure you have all the right tools to handle this smoothly if it were to occur on your production servers. And about myself, I've been working as a SQL Server database administrator for 10 years now, based out of Boston, Massachusetts in the US. And I'm very passionate about databases, especially the internals, working off the SQL Server engine, and performance tuning has always been intriguing for me. And I work a lot on AWS EC2 instances with SQL Server installed on them. So I worked on the certification and got the AWS Certified Solutions Architect thing done. That helps too. And then for the work I did last year, I won an award at work, that is Rookie of the Year. So that's about me. And on the personal end, I have 2 kids and my husband, so that equals 3 kids. But yeah, you can take it. But yeah, I should thank my husband. He helps with the kids, and he helps me a lot doing this kind of work. All right. And then the agenda for today, I will be skipping the basics of TempDB and covering the intermediate level concepts. So I'll be discussing how TempDB contention occurs, what are the different types of contention, and how to identify when it occurs, and what are the different ways we can resolve this. And like I said, I will be making pauses in between, and for any questions you have, then we can have a discussion. All right. So what is the need to learn about TempDB contention? First thing is, when you have multiple processes in TempDB, that creates a slowness in the system. So to troubleshoot that slowness, you need to understand what this contention is all about. Only then we can address and resolve the slowness in the system, because slowness on TempDB equals slowness on the system too. And speaking about concurrency management, at any given point of time, you have thousands of concurrent transactions running on a production server. And to manage them all effectively, it is very important to understand how this contention occurs and how we can identify and resolve them. At the end of this session, we will be able to pin back to the slide and understand how we resolve slowness and how we are managing all those concurrent transactions. So why is there contention on TempDB? What is special about TempDB? If you look at any user databases, let's consider on a server we have like 6 user databases, for example. You have a certain amount of insert, updations on user tables, and a very few create, alter, or drop, right? But if you take TempDB, you are constantly inserting, updating, deleting from the temp tables and creating temp tables, dropping temp tables, or altering them. Not just that, doing table variables or any other temporary stored procedures, or if you have snapshot isolation levels. And also remember, we have work tables, work files, doing those spools, merge joins, hash joins, whatnot, also online index operations. So all this work happens on TempDB. There is only one TempDB for the whole SQL Server. So all those transactions run on this TempDB, where the workload is 10 times more or even 100 times more, causing contention on TempDB. So that's why you see contention on TempDB very frequently than any other user database. And that's our point today. So how this occurs and how we are going to resolve it. So what are the different types of contention? We have two types of contention: object allocation contention and metadata contention. So we will look at each of these two types in detail. So the first one is object allocation. How does SQL Server allocate an object? So to allocate an object, SQL Server needs to know which page is full, or how much of a page is full, which page is allocated, and how much of a page is allocated. Now, all this information is provided three special pages called PFS, GAM, and SGAM. So, under normal circumstances, when you have insert, update, and delete transactions running, now these transactions, they need to acquire a latch on these PFS, GAM, and SGAM pages to gain access and modify the page. But on TempDB, when of concurrent activity, there are now too many of these insert, update, and delete operations. Now all these operations have to wait in line to obtain a latch onto this PFS, GAM, and SGAM pages, and that causes contention. So if you look at this, we have insert, update, and delete transactions on temporary objects. They all need a latch on PFS, GAM, and SGAM pages. And when you have too many of those, that causes contention. Because under normal circumstances, you have just a few of those and they can easily get a latch. But when you have too many, it is hard for it to obtain that latch on these three special pages. And that leads to contention. This is called object allocation contention, because to allocate an object, it waits for a latch and that causes contention. That's why it's called object allocation contention. So I mentioned about PFS, GAM, and SGAM pages. I quickly want to show you what these three pages are. So PFS is nothing but page free space. This is an 8 KB page by itself. And let me zoom in. Let's just focus on the PFS page for now. So this is page free space and it's an 8 KB page by itself. When you do DBCC page, you can get this internal details of a page. So I just grabbed a screenshot to show you how this PFS page internally looks like. This first one is the file ID and this is the page number. File ID 1, page number 0 to file ID 1, page 3 is allocated 100% full. You see how it says, and for 4 and page 5, it says not allocated, 0% full. So this is how PFS page contains the free space information, 0%, 100%, which page is allocated, and 50%. If you see one of the pages here, that's 50%. So this is how PFS page looks like, and that's why those transactions need a latch onto this PFS page to get the information. And the other special pages, GAM page, this is global allocation map. Again, this is an 8 KB page by itself. It contains the allocation status of uniform extents. An extent means 8 pages. Uniform extent means all those 8 pages contain the data of the same object. All right, so I don't want to go into too much of details that might confuse you, but just to give you an overview. So again, GAM page contains information like this: file ID 1, page 0 to file ID 1, page 150608. You see how all these pages are allocated. And this page, it says not allocated. So this is how GAM page contains the allocation details of the pages, of all these data pages. SGAM, it's almost the same thing, but it's a shared global allocation map. It will contain the allocation status of the mixed extents, where all those 8 pages will contain data of different objects. So the whole concept here is, you see how these PFS GAM and SGAM pages look? They contain the free percentage information, they contain the allocation or non-allocation status. So this is what these 3 special pages have. And that is why SQL Server transactions need to obtain a latch onto these 3 pages to find out the status information of the pages to allocate the object. Right? Okay, so now if you see this picture, you see how all the transactions are hitting on this data file, trying to acquire a latch onto this PFS GAM and SGAM pages, and that causes contention. All right, so this is just one data file, and PFS, GAM, and SGAM pages are always page 1, 2, and 3 in any data file. And one PFS page can contain the free space information of 8088 pages. So for every 8088 pages, you will have a new PFS page popping up. Similarly, one GAM and SGAM page can contain the information of 511,232 pages, the allocation status information of all those pages. So for every 511,232 pages, you have a new GAM page followed by an SGAM page. So this is how a data file is. And if you want to find out why this specific interval, I'm not going to go into details now about the numbers, but I've written a blog post if you're interested in taking a look at it. Okay, so now we know how this object allocation contention occurs. It's because of too many DML operations trying to acquire a latch on PFS GAM SGAM, and that causes contention, right? Now let's see how to identify it. I will show you in the demo shortly, the query to run so that you can get this information. But for now, I've just grabbed a screenshot to show you. You will see page latch, wait type, and then the first number is the database ID. Second is the file ID number, like the number of data files you have. If you have 12 data files, this number can be anywhere between 1 to 12. And then this one is the page number. You don't have to worry about page because we have this page type description column in the TempDB page info function, which can grab what page is this, page number. So in this case, page number 2 is GAM page. I mean, we already know that page 1, 2, and 3 are PFS GAM and SGAM, but you don't have to remember it because it can display what the page is, page type is. Okay, so once you see page latch on TempDB ID 2, and it's either on PFS, GAM, or SGAM, then you know it is object allocation contention. And how do we resolve this? So now we know how this occurs and identify it. Let's see how to resolve this. Bringing this picture back where you have multiple transactions trying to acquire a latch on one data file causing contention. Imagine we have 4 data files. So now you have 4 sets of PFS GAM and SGAM pages. Now the transactions are all spread across those data files, and that reduces contention. So this is the reason why you add more number of data files on TempDB, because the transactions get spread across, because you get more number of PFS GAM and SGAM pages, and that reduces contention. And not just this, there was also an enhancement in SQL 2017 with PFS page, where the allocations not only round robin within, but also across the data files. Let me show you here. If you see now, You see allocation 1 on PFS page, and then allocation 2 goes to the next data file, 3 here, and then 4, and then 5 comes back here now. It doesn't do 1, 2, 3 on the same data file. It goes across and then within the data file. So that reduces contention on 6 and then 7 and 8. So we see that round robin across the multiple data files and also across the PFS page reduces object allocation contention. Now that being said, how many data files should you add? If you have 4 processors, add 4 data. If you have 8 processors, add 8 data files. If you have 16 processors, start with 8 data files. And that is what the SQL Server install will also give you by default. Always start with 8 data files. In this case, when I say just data files, it means TempDB. Okay, so start with 8 data files. Check for contention. I'll give you the query in the demo. I'll show you that. Check for contention. If you have contention, now add another 4 data files. Again, check for contention. And if you still see a lot more, you can also add 8 data files, not just 4, because you know there's going to be a lot more. Add 8, again check, then add another 8. You will find a, like at some point, you will find that sweet spot where it can actually stabilize, where you will see that contention getting stabilized. So at that point, you can stop. But on all the versions except 22, you will probably not be able to completely get rid of this contention, but you should be able to mitigate it to some extent, like maybe 70% or 80%. For example, in one of the servers that I worked, I had like a 192 processors, and this is on production. And on dev and test, I had like, I think 32 TempDB data files. So on production, though the install came with 8 data files, I'm not going to be starting with 8, right? Because on dev and test, I know I already have 32 data files, and considering the workload, and I know the environment and the pattern. So what I did is I started off with 48 on production, because I know it needs a lot more than 32 for sure. So I started off with 48. I checked contention, added another 8, and then checked contention. There's just a lot more, and then added another 8, and then I ended up at 96 data files for 192 processors. So, at that point, I think I was able to mitigate like almost 80% of the contention. So it was not able to completely get rid of it. There will be a little bit. So it needed 96 data files on that server. Well, that is one critical server with a lot of workload on it. So that's an example of, when you start working on it, you will get the hang of it, like how to add data files or when to add it, like how does the pattern look, the workload looks like, should you stop it? Once you start doing it, you will know, like, how to do these things. And talking about adding data files, what will be the size of it? They should always be in size. That's very important, because when you have files of equal size, then SQL Server does round robin algorithm, which means it will round robin across the allocations. If you have unequal sizes, which means one file is bigger than the other file, that also means one file has more empty space than the other files, then all the transactions will start hitting onto that bigger file, causing a hotspot, which is exactly what we don't want. So that is why create the files with equal sizes, because for unequal sizes, SQL Server follows proportional fill algorithm, where it tries to proportionally fill the data files based on the empty space. So we want to trick SQL Server into following the round robin algorithm, because that will reduce the contention. All right. Other thing is, when you have the opportunity to restart the SQL service when you add the data files, please go ahead and do so. If you are in the maintenance window or off hours, and if you can do it, go ahead and do it. Because when you restart the service, TempDB gets started from scratch, which means all the old data files that are there and all the new data files that you are adding, now all of them are going to be starting from equal size, which means equal empty space, which also means all the transactions will do round robin across the files. And that's like an advantage, a bonus for us. But if you don't have the opportunity to restart the service and you are in the middle of a business day or business hours, that's still fine, you don't have to. But if you have that opportunity to do it, please go ahead and do it. So the main point here is have multiple data files, so you can do the round robin across the data files, and that will reduce contention. And when you add data files, make sure they are of equal size and check for contention and keep adding the data files either in numbers of 4 or 8. All right. And if you go by the server version, I really hope you're not on 2014 SQL Server version. It went out of support last July, so I really hope you migrated. And if you see in 14 or older, right, you will have these 1117 and 1118 trace flags for, I think, the auto growth and the mixed extents. From version 16, you don't have to turn them on because it is already on by default. So these were like very two important trace flags back then, but not anymore because it's just in the box itself. We don't have to manually add it. So that's a good thing. And in 2019, this is a very good one. You know how this contention occurs? If you recall, it's on PFS, GAM, and SGAM page because all the operations are waiting for that latch, right? So what they did in 2019 is just on the PFS page, all the latches, they were updated to shared latch. They don't need to grab an exclusive latch anymore. All those operations can share the latches onto the PFS page. And that reduced a lot of contention. I shouldn't even say lot, that absolutely reduced contention on PFS page on 2019. So that's a very good enhancement in 2019. But on 2019, you will still have GAM and SGAM page contention because they still need exclusive latches. All right, so 22, here we go. The contention still remains on GAM and SGAM, right, until 19. So what they did in 22 is they updated all the latches to shared latch. Now all the transactions, they can share the latches onto GAM and SGAM pages too. And that was like one of the biggest improvements or enhancements for TempDB. And that reduced this object allocation contention on TempDB. Not just reduced, it actually got rid of it completely. You don't have to add data files in 22 version anymore because this PFS, GAM, and SGAM pages contention have been addressed in the box itself. So we don't have to worry about, should you add 48 data files? Should you do 56, 96? No. So you will not have that problem with 22 version because this 3 pages contention has been addressed. Well, that being said, you still need to follow all the best practices across all versions. And also, I would like to tell you this. So on one of the servers that I worked, which was on 2014, I had, I think, 56 data files on a production server. And to move them to 22 version, now the 22 hasn't got that PFS, GAM, SGAM contention, right? So I don't need 56 data files. So can I just do 8 data files? And I should be fine, right? Because according to the documentation. So in one of the support tickets, when we talked to Microsoft, we were like, hey, can we just do 8 or 16? Should we do all the 56? But the recommendation from them was, it is also quoted in the link that I have put in the resources tab if you want to take a look. So the recommendation from Microsoft is just bring over whatever you have. Don't make any changes. So if you have 48 or 56 data files, just bring them all over. Don't make any changes in 22 when you do the migration. That's what they said. But if you are creating a new server, you're just building from scratch on 22, then try with 8 data files, see how things are. I'm sure it should not have contention because it's resolved in the CPU level itself. So the point that I wanted to mention here is, so whatever you have on the previous versions and you are migrating to 22, just bring them all over. In our case, I think we were not bold enough to, should we reduce it? I'm like, maybe not, because it's production. And then, if something goes wrong again, this is the Microsoft's recommendation to bring them all over. So we just left it there. So that's the point I wanted to mention. Okay? Bring them all over. And if if you want to try it out, go ahead and try it out. But we haven't done that. I have done it on my sandboxes with, stress testing them, and I absolutely didn't see any issue. They were just fine with 8 data files. So if that's something you want to try, go ahead and try. But these are the recommendations, the official recommendations that you have to be doing. All right. So the point here is, to summarize this type of contention, on 22 version, you will not see this contention at all. So if you are having bigger issues with this contention on the previous versions, consider migrating to 22. And Microsoft doesn't pay me for this, okay? So, what I have seen with 22, I loved it, and that's why I wanted to mention this here. So that's the beauty of 22. And otherwise, on all the other versions, you still have to add data files and try to mitigate the contention. All right. This brings us to the end of first type of contention. Any questions?
There are a few in the chat. I think they have been addressed also in the chat. It's good with helpful people.
Okay, that's nice.
There is one request. Can you post the link of the blog of pages structure into the chat, and maybe not?
Oh, sure. Yes. Yeah. At the end of the session, yes, I will post the link.
Perfect. And then Alexander had, what do you mean by too much? Do you have a number? But I don't know exactly what he referenced in the question. Can you clarify, Alexander?
Sorry, which one is that? You asking me?
Alexander Lutsky asked 8 minutes past 12. What do you mean? What do you mean by too much? Do you have a number? So number of latches, and I guess that depends. Or
you mean the page latches?
Yeah.
How many page latches? Oh, okay. So yes, I will be showing that in the demo. You will see, I think, like from what I saw last time, you could have 5,000 page latches or 10,000 page latches. It differs. When you start adding data files, the number of page latches will go down. Yes. Yeah. I will be doing the perfmon. There you can exactly see how many page latches we are getting every second. So I can point that out, Alexander, when we do it, so you get a clear idea.
Yeah. Yeah, and I think how many latches are too many, that kind of depends on how long they are held and so on. So I mean,
yes. If you don't how many latches are too many? Yeah, I don't think we have a exact number. Like Magna said, it's like for how long those latches are there. That's very important, because more number of seconds or minutes they are there, then more contention it is, and it's going to block the other things too. So that's not good.
Yeah.
Yeah. And the post the link, yes, I will post the link. And difference between page latch and page IO latch. Yes, I was going to say that in a few minutes though. So page latch, it is those operations waiting to acquire a latch on the page, PFS, gamma, or anything. So a latch means a lightweight lock. So that is a page latch, to get a latch onto the page. Page IO latch is completely different. It's to bring the pages from storage to memory. So that is page IO latch. So we are not discussing page IO latch here. That's a whole different topic. It's just about page latch here. But I do appreciate the interest between page latch and page IO latch. Page IO, moment you see IO, that's from storage to memory in the page IO latch wait. All right. Oh, okay, someone already answered that. Good. And there will be no TempDB contention. Yes. Okay. So that's the, what do you call it? So that will be like an interesting point here that I will be talking about. If you won't see any TempDB contention, there is TempDB contention, and I'm going to be talking about it more. Okay, well, databases are still latched, but yes, the improvement in 22 makes it okay. All right, okay, that's good. Good. Any more questions as of now? All good?
I think we're all good for now. Looks okay. Empty in the chat.
Okay, great. All right, so we will move to the second type of contention. Let me point it here. That's the metadata contention. This is of the DDL type. So when you have create table or drop or alter table, now these DDL operations, they need to check and insert metadata into system tables. So when you have a few operations, a few create or drop tables, yes, it is easy for these DDL operations to get a latch onto the system tables. But when you have too many operations going on, like you're just constantly creating temp table or dropping temp table, when you're just having too many operations, now these latches again have to wait in line to get a latch onto the system tables and causes contention. If you look at this metadata contention is about create, alter, or drop, just the DDL operations, and they need a latch on the system object pages. The same concept. You have too many operations, they'll be waiting on the latch. That causes contention. So the difference between the earlier type of contention is there we have to wait for a latch on PFS GAM as GAM pages. Here we will be waiting for a latch on the system object pages. So that is the big difference. Okay. So now you know how this metadata contention occurs. Let's find out how to identify it. Okay, so yeah, before we go ahead and identify, I just want to show you this quick picture where you see how you have too many of those operations trying to get a latch onto the system table, and that causes contention. This is just one of the system tables mentioned in the picture. But actually, all these DDL operations need access to 12 system tables, not necessarily all the 12 at the same time, but it needs to check and insert metadata into a few of those 12 system tables. All right, and I've posted the link for this one if you want to take a look at this picture and the details behind it. And how to identify this? It's the same concept. You have page latch on TempDB ID 2, but the page here is different. Instead of PFS GAM as GAM, in this type of contention, you will see system object pages. The moment you see contention on these system tables means metadata tables, then you know it is metadata contention. So that's why it's called metadata contention. You're seeing a contention on these metadata tables. That's why it's called metadata contention. And we will see how to resolve this. First thing, do not explicitly drop your temporary tables. I know we all have the habit of cleaning up our temporary tables at the end of the session. You don't have to drop them. Leave the job for the SQL Server to do. SQL Server will clean up the temporary tables for you. What it does is it drops the tables asynchronously behind the scenes, which is based on the optimistic latching algorithm. And that algorithm works based off of the number of concurrent create or alter drop operations and many other factors, which I'm not going to go into detail about the algorithm. All you need to know is do not explicitly drop the temporary tables. SQL Server can do the job for you. All right, because drop operation, again, it needs to check and insert metadata into the system tables. So it waits for a latch onto the system tables. When you have too many drop operations at the same time on a server, that will cause contention. To reduce the number of page latches, we have to avoid dropping the temporary tables. So if you go check your production code, I'm sure many of our stored procedures have drop temp table, drop temp table. We're just so used to dropping temp tables. So you can go check that out and you can take them off. You don't have to drop them. SQL Server will do that for you. So you can reduce the number of page latches on your server. Page latch is nothing but contention. Okay, so if you think it that way, for easier understanding, I'm saying that. So if you think of that way, you see more page latches, then it's contention. All right, so do not drop the temp tables. And the other important thing that I cannot emphasize enough is cache your temporary objects. This is very, very important. Cache your temporary objects, because when you cache your temporary objects, they are stored in memory and that reduces a lot of page latches. So what are the rules to cache the temporary objects? First thing, when you create the temporary table, alter the DDL of the temporary table after its creation, which means, look at the code here. You see, you have create temp table, and then do not create the index of the table definition. You see this here, how create cluster index. Do not do that, because once you create an index out of the table definition, that means you are altering the DDL of the table. When you alter the DDL of the table, it cannot cache this temporary table. That's very important to understand. So do not create index outside of the table definition, which means you're altering the temp table DDL. It cannot cache that table. I will just keep saying this a million times because it is that important to reduce contention on TempDB, all right? Instead, what you should be doing is create the index, whatever you want to do, create them in line with the table definition. You see how I brought this inside? It was earlier over here, right? Create cluster index or create non-cluster. Do not do that. Just go inside the table definition and create the indexes here. You can either put them here or also next to the columns. But in case you want to add multiple columns to the index, that's why I just created it here. You know, you can do the column names and then do the index just inside the table definition itself. If you do this, it won't alter the table DDL because we are already inside the definition. In this case, you will be able to cache the temporary object. And that's very important because once you cache it, it reduces a lot of page latches, because we have in many of the production servers, we implemented this, and you won't believe me. It is like we reduced more than 50% of page latches. For this metadata contention, we were able to get rid of more than 50% just by caching the temporary objects in our stored procedures. So this is very, very important. If you go take a look at your production code, you will find so many number of temp tables where we have the indexes being created outside and that will not cache them. So if you can go work on them on your dev or test environment, difference. All right. And then there's also another rule, which is when you create the temp table, don't send it as an ad hoc statement. Create it inside a stored procedure or a trigger or a function. I don't like functions, but yeah, usually we create them inside the stored procedure. So try to ramp them up inside the stored procedure. That way it can get cached. Okay, so these are the important rules to reduce metadata contention. First thing, do not drop your temporary tables. That will reduce the page latches. And the second thing, cache your temporary objects by not altering the DDL. Do not create the index outside of the table definition. Create the index in line with the table definition, and then wrap them up inside the stored procedure. This will all help cache the temporary objects and reduce a lot of contention. Once you do all this, you should be able to see like 50 to 60% getting resolved. And if you still have metadata contention, what you can do is, in 2019, there was a new feature introduced called in-memory TempDB metadata feature. What this does is, this is also part of that, the in-memory OLTP that we have. So this is also part of that umbrella. So what this feature, especially for TempDB, what this feature does is, it moves all the heavily utilized system objects, the 12 tables that I talked about. It moves all the heavily utilized system objects to memory, making them latch-free. So that's this feature is all about. So when it moves all those system objects to memory, it will make them all latch-free. So you should not see any latches. And this feature is actually disabled by default. You have to turn it on manually. And for this feature to take effect, you have to restart the service after turning it on. So that's about this one. And also, there are 12, I said there are 12 system tables that you can see metadata contention on. So this feature moves all these 12 tables to memory. This just the system tables. This is not about user tables at all. It's just the system tables. All right. So this brings us to the end of
second type of contention, that is the metadata contention. Any questions?
We have not a question, but a comment that sometimes if you create one temp table with the same column names as another temp table in another stored procedure, but with different data types, SQL Server is going to use the cached object, but that's going to be the wrong object because it has another data type definition. So it could lead to bugs. And my question around that is, if I mean, to me that's a bug in SQL Server and should be reported as a bug to Microsoft to be fixed, I guess.
Yeah. Anything else? I'm just trying to read. Yeah, it takes some time for me to just.
So no, I don't see any questions. Only these, and also a comment about creating the indexes inline. If you need to load a temp table with a lot of data, then it's probably going to be faster to create the indexes afterwards. And yeah, there is no rule without any exceptions, I guess.
Yes, there are exceptions. Yes, like for anything you do have exceptions, but I will strongly recommend you to test it out. Like, do a test on the on one of the dev environments to first load the table and see how things are. It also depends upon how many things you are doing in the store procedure after loading. So I would recommend you to first test it out, create then test it out, how many page latches or how much you're seeing, or do it vice versa and test it out. But there are exceptions to it. If you have like billion rows insertion or something, then I would say, yeah, go with inserting the data first and then creating. But again, test everything out. You may see different results from what we expect. All right.
Good.
Let's go into the demo now. So in the demo, I will be showing you on contention on 2019 and contention on 22, and we'll see how it differs on both of these versions. All right, so this is on 2019. Let's see what is the, okay, we have 2019 CU27, 14 processors, and by default, I have 8 TempDB data files. What I'm going to do now is, I actually borrowed this idea from Klaus Askenbrenner. So it's just a simple store procedure. What I'm doing is creating a temp table with 3 columns, creating a primary key, and then inserting 10 records into it. All right, and I'm not dropping the temp table or not altering the DDL outside. So that is good. And let me go ahead and run this store procedure. After this, now what I'm going to do is use the OStress utility. This is one of the free tools from Microsoft where you can stress test your server, generate the workload against the server and see and troubleshoot the issues that come out of it. Before I run this stress test, I want to show you the contention query that I'm going to be using when we run the load, how we are going to check the contention. So this is the query. What it does is it grabs data from this DMV, which only displays the active request, and DMXX equal text in conjunction with this DMV will give you the text that is running because the SQL handle gets passed here. So we can see what text it is running for the active request. And then FN page rest cracker and DMDB page info. These 2 functions are new with SQL 2019, where you can get, detailed page information, and especially that helps with troubleshooting any page related waits. And I'm filtering this whole result set with only for page latch because we are interested only in TempDB contention now. So we are only, so I'm filtering it only with page latch. And like I said, this has nothing to do with page IO latch. So that's a whole different thing. In this demo here, we are only worried about page latches. All right. So let me go ahead and run this OStress utility. So this is the query. OStress.exe is the executable server name, and then this is the store procedure. N50 means run on 50 concurrent threads, and 1000, R1000 is the number of times, 1000 times. So I'm running this 1000 times on 50 threads. Okay, so let me go ahead and run this. Okay, so this is running. Let's go ahead and check the contention. All right, we see contention. Okay, before this, let me just minimize my PowerPoint because I can't see the windows on the screen. And slideshow. Okay, this is good. Okay. All right, so we have page latches here. So you see TempDB ID 2, okay, page latch on TempDB, and you will have this on system objects, which is nothing but metadata objects. So this is metadata contention. I'm going to scroll all the way to the right. You see metadata contention, and then scroll all the way to the end. So all we see right now is metadata contention. And the ways to resolve metadata contention is first take a look at the query and see if practices, which is like we are not altering the DDL, not dropping the temp tables. So this is all good. What I'm going to do now is turn on the feature, which is the in-memory TempDB metadata feature on 2019. So because this will bring all those system objects, the heavily utilized system objects to memory, and it should get latch free. We have this 0, which means it's disabled. Let me go turn this on using this alter server configuration. When I turn this on, it needs the service to be restarted. So I'm going to restart from here. But when you on your servers, please do restart from configuration manager for a single node or clustered instance. Then do it from the failover cluster manager. Don't do it from here. And also, if you have multiple nodes, make sure you do it both on the active and passive nodes or on all the secondary nodes. That way, when you do the failover, it is consistent across all the nodes. Now that I restarted the service, I should see this one that is enabled. That's good. And let's check now. We should see 12 tables now that have been moved to memory. So this query here, all objects joined with this memory optimized tables, should show us if all the tables, if all those system tables have been moved to memory. All right, we have 12 tables here. That's good. And let's also check how much memory this is actually occupying. I'm doing this with DMOS memory clerks and only filtering it for TempDB ID 2. Okay. So let's go do this. You will see just 82 MB. It doesn't take that much space at all. This is good. Okay, so I've enabled this metadata feature on TempDB. Let me go kick off the same workload and check on 2019 how this looks. All right. Now I see GAM page. I don't see the system objects. I want to move to, okay, all I see is, okay, I don't see metadata contention. That's good. We were able to get rid of this metadata contention. We have a new problem that is allocation contention, which means you have contention on PFS GAM SGAM pages, and we can get rid of this by adding the data files, right? So let's check the number of data files we have. I think we started with 8. Before I add any data files, what I want to do is get this perf on. I'm on 2019. Okay, I'm grabbing the page latches and batch request here. What I'm going to do is I'm using perf now because I want to see how many page latches we are getting. And after I add the data files, I want to see if we are able to see any reduction in those page latches. Okay, so let me start this and just kick off the load. Let's see here. Okay. Okay, there we go. So you see 12,900 page latches. The red one is the page latches and green is the throughput. So red, you see almost 12,000. All right, 14,000 now. You see this is the number that we can see. All right, let me stop it. Okay, so the workload is done. So I've stopped it here. So we know like it went up to 14 to 12,000. What I'm going to do now is add the data files and see if it reduces anything at all. Okay, add 9, 10, 11, 12 of the same size. All right. And start this again now and then kick off the workload. Let's see how it is. Okay, page latches should go up. Okay, 6,800. Okay, 7,000. So we see almost like 50% reduction in page latches just by adding 4 data files. So you see the difference now. So the reason I bring perfmon up is on SSMS, you could still see like, okay, so, oh, I had some page latches. I see some reduction, but I will not know the metrics exactly. Like, did I reduce 50%? Did I reduce 80%? So how much were we able to achieve? So for you to make that informed decision of, oh, should I stop at this point? Did we reduce enough? So to make all those informed decisions, it's good to use Perfmon, and that's the reason I use it too. And to a person who asked me that question about how many is too much, or I think, yeah, something related to the number of page latch. So I would recommend using Perfmon, so you could clearly get an idea. Okay, there were 15,000 page latches earlier, and now we were able to reduce it to 7,000 and something, close to 8,000. So that's a 50% reduction. What I'm going to do now is just add another 4 more to see if we see any more reduction. Otherwise, I'm going to stop at that point. Okay. All right. So here we have 12 data files. I'm going to add another 4 more equal size and make it to 16. So I think I should see 16 in total now. Yes, I do. Okay, we have 16 data files. That's good. Let me turn this on and then kick off the workload. Okay, where's the red one? It's going up, 2,800. Okay, that's good. So we were, okay, it's going up again, 7,000. All right. All right, okay. So you know what, I'm going to stop at this point because I don't see any more reduction. It's like 8,000 or 7.5 years, the same thing. Not a big change, not a significant change for me to keep adding data files. So I'm going to stop it at this point. So this is how you can make, you can get the idea of, okay, I can stop it at here because I don't see any improvement. So all we did is we turned on that in-memory TempDB metadata feature and got rid of metadata contention. And the second thing we did is we added 4 data files, and we were able to see, again, a 50% reduction in page latches on PFS Gamma Scam. So on 2019, you see that this allocation contention, we were not able to completely get rid of it. You can mitigate it to some extent. So that's the point of, reducing this allocation contention on 2019. Let's go take a look at 22 version. Okay, 22. Yeah, it's the same thing. I have 8 TempDB data files that came with the install and 14 processes. This is the 22 version. I'm going to be using the exact same procedure that I just used in 2019. Okay, I'll create it here, and I will use this OSTRES utility. The only change is the SQL Server name here. So let me go ahead and run that. Before that, let me keep my contention query ready. It's the same query that I used, in 19. So I'm going to be using that. Let me go ahead and run this. Okay, this is still 2019. I didn't copy it correctly, I guess. Copy. And then go here. Okay, so this is on 22. That's good. This is running. Let me check contention. What do I have? Page latch on system objects. So all this is metadata contention. Okay, so all I see is metadata contention. And we know I'm going to go ahead and turn on that in-memory TempDB metadata feature because it is off by default. Let me turn this on and then restart the service. Set on the other side. Okay, so this is getting restarted. Yeah, probably take, okay, so that is done. And then if you check now, you should have it enabled. That's 1, so that's enabled. Now, if we verify it, you should see all 12 tables moved. 12. And then if you check this, 81 MB, so that's just very less, so that's good. Okay, so now we have this metadata contention enabled. I'm going to run the workload. Shouldn't see this metadata contention. Okay, so let me go ahead and run the same thing. Let's see if we see anything now. Okay, we don't see anything. That's good. So metadata contention is gone, but also allocation contention is not here. But before, I totally trust SSMS because we might be missing any contention if there is. So I'm going to turn on the Perfmon too, just for a quick check if we see any spikes here. So I will let this workload finish. Okay, this is done. So this is on 22. If you see, this is on 22. Page latch is the same thing. So I'm going to turn this perform on and run the workload. 22, right? Okay, that's good. Let's see if we have any page latches here. In 22, we have only turned on that in-memory TempDB metadata feature. We haven't added any data files at all. Let's see. Okay, it's at 0. Page latch is at 0. Absolutely no spikes. Okay, so the workload is done. So you see, there was absolutely no page latches in this case. We haven't added any data files at all. So like I said, that's the best part about 22 version. You will not see this type of contention from the data files or anything because this has been fixed by default within the box itself. So that's so good about it. Like we saw in the demo, we did not see object allocation contention on TempDB in 22, but we still see metadata contention. So the whole point here is only one type of contention is resolved, which is the object allocation contention, where you add the data files. That part is resolved in 22. You still have the metadata contention, where you have to cache the temporary objects, or you have the need to turn on that in-memory TempDB metadata feature. So you still have metadata contention exist on 22 version or on any versions, but on 22, TempDB contention is not completely resolved. You still have that issue. TempDB contention issue still exists, but just on the metadata parts. Okay, so that's about this. And also, I want to show you one good example for caching. Okay, I'm going to free the cache now for all the tables that we did. I'm on 22. Okay, I'm using 22 version. It really doesn't matter what version you use. What I want to show is I'm creating that exact same store procedure that we have been using, where we are not altering the DDL and we are not dropping the table or anything like that. The idea here is I'm going to run this stored procedure to create the temp table 100 times in 10 loops, which is for 1,000 times I'm going to be running the stored procedure. So you see how many temp tables get created, because for each creation we should see one table. So for 1,000 creation, you should see 1,000 tables. But since our temp table gets cached here, let's see how many temp tables get created in this 1,000 executions. All right, so I'm doing this with the perfmon counter. Where is that? Yeah, here is the perfmon counter, and we are checking how many temp tables are getting created. Okay, here we go. Let me pull this up. It just took a second, and then you see for all the 1,000 executions, all it did is one temp table, and it reused the same table from cache, and it didn't have to create any more tables at all. And it took less than a second, and I want to show you the cached table here. If you see that one table, it was able to cache that table. So for all the 999 execute, was just able to reuse the table without creating any more tables. Now what I'm going to do is, on purpose, I'm going to go ahead and alter the DDL of this table by creating an index outside. So when we do this, it will not be able to cache the temp table. I'm doing this on purpose to show, so for this 1,000 executions now, how many tables we are going to create. Okay, so let me go ahead and run this. So here I'm altering the DDL. It won't be able to cache. And let me run the perfmon counter again. Let me bring this up. Okay, so this is what I'm going to run. Let's see. Last time it was able to cache the table, created only one temp table, and it took less than a second or maybe a second. Now you see it took 6 seconds, and for every execution, it created a table. So you see for all the 1,000 executions, for every single time, it had to create a temp table. And you look at the execution time here, 6 seconds. Last time we had only 1 second. So the query execution slows down if it's not able to cache the table because it has to recreate every time. And imagine the number of page latches it had to be there to do all those create table operations. Now let's see if any table is cached. The expectation here is it will be 0 because it was not able to cache the table. You see this? It was not able to cache the table. That's why it had to create a table every single time for all those 1,000 executions. And also the time it took was 6 seconds. which is 5 seconds more than when it was stable. So that's the important part about caching. Caching is very important. So if you have the chance, go ahead and test it out and implement caching on your temporary objects in the stored procedures. So that brings us to the end of the demo. So we saw two versions, 2019 and 22. 2019, we were only able to mitigate the allocation contention. On 22, we didn't have to do anything with allocation contention. That's resolved with the box. And for metadata contention on both the servers, we have to manually address it. Okay. And I just want to, I know we are almost there, but I just want to quickly show you a couple things. Okay, so the common mistakes that I usually see with people, the misconception or on Stack Overflow, Stack Exchange, I see this a lot. The moment you see page latches on TempDB, it's not always about data files. There's also an other part that is the metadata contention. So when you see page latches on TempDB, it is not always about data files. There is also other part to it. So please pay attention to it when you see on your SSMS what it is about. Okay. And the next thing is TempDB contention is not fully resolved in 22. This is a huge misconception that people have, that TempDB contention is resolved. No, it is not resolved. Only the allocation contention is resolved, where you add the data files, that part is resolved. Metadata contention still exists. You have to manually address it. Okay. And then the third part is the feature that I talked about, the in-memory TempDB metadata feature. This will, while using this is not a mistake, but just be cautious when you use it on SQL 2019. It's also throwing out of memory errors on 19. So I would advise you use this with caution on 2019. On 22 version, this feature works fine. It has been performing reliably, but on 2019, use this with caution. Test it, do a thorough testing on your lower environment, and then promote it to production if you are planning to do it. Okay. And then I quickly want to show you this flowchart. I know I've given a lot of information this past hour. Even if you don't read or if you're confused with something, just have this flowchart handy and it will help you get to the resolution and what or where you have to resolve this. Okay, so the first thing, do you see page latch? Yes. Is that on TempDB? Yes, that's very important because you could see page latches on the user databases too, and resolving that will be different. So make sure it is on TempDB. Now go to the next part. Do you see it on PFS, GAM, and SGAM pages? Yes. Then add 4 data files of equal size. Now again, check contention. You still see contention? Add 4 more data files of equal size. Again, check contention. If you still see it, keep adding, and you will be able to stabilize contention at some point. Okay. But if you are not seeing this on PFS, GAM, SGAM, instead you see the page latches on system objects. What should you do? Work on caching the temporary objects and avoid dropping the temporary objects. So do this in your stored procedures. You will be able to see a lot of reduction in page latches, which means reducing contention. But if you still see contention now, what you can do is add that in-memory TempDB metadata feature in 22 version, because 2019, you have to do a thorough testing. There are out-of-memory errors. 22, it's good. Okay, so these are the things. This is how, this is how my processing, this is my thought process. Okay, I'm seeing this. What do I do next? Okay, I'm seeing this. What do I do next? I don't see this, but I see system objects. What do I do? Okay, so this is how this flowchart should be very helpful to you when you see TempDB contention. And also that part in the green box, only that is resolved in SQL 2022. I am emphasizing it again and again because you still have this contention, the metadata contention, the last 4 pieces, it still exists even on 22, and you should manually address and resolve it. Only that green box part is resolved in 22. Okay. So that's about this. And then talking about why do we need to learn this contention? You see how we addressed slowness by reducing the number of page latches, either, by caching the objects or by turning on that in-memory TempDB metadata feature and addressing the concurrent transactions. Like how do you effectively manage them is by adding more number of data files in versions lesser than 22. Then you will be able to address all those concurrent transactions on TempDB. All right. And these are some very, very good resources you can take a look at. All the points that I talked about, or any details. Microsoft has a lot of documentation that are very helpful. You can take a look at that. And so that's the Substack newsletters that I send out. Also, the GoHigh.substack, that's where I have about this PFS, GAM, SGAM pages, more information about this metadata contention, allocation contention. I know someone asked about the blog post. You should find it on the Substack. And if you have any questions, we can discuss now. And also you can DM me on LinkedIn. And you will find the slide deck, this whole presentation, demo scripts, everything on my GitHub. And also that's my email ID. All right, any questions?
No more questions, but yeah, there is actually one. Well, it's what about Azure SQL Database? Where
what is it?
What about Azure SQL Database where we can't control?
Oh, sorry, I don't work on Azure. I just work on AWS, so I'm not sure about Azure. But one thing I know about Azure is that what I've heard from people is in-memory TempDB metadata feature is not on Azure yet. If I'm not, that's what I heard. But I don't work on Azure, so I have no clue about it.
No, and John answered that these features are sort of on by default because it's the evergreen version of SQL, so all the new features will come to Azure SQL first, and then to then I don't know if the in-memory TempDB metadata is on by default, etc. But I guess the key thing is that if it's not, you can't control it anyway because you're not in control of TempDB on Azure SQL. So.
Okay, yeah, Azure I wouldn't know. But on this one, on these SQL servers, in-memory TempDB is not on by default. It's off by default. Yes, it's off by default.
Yeah. So I just want to thank you. It was great. I've seen, I mean, it was a similar presentation. You added a few things since I saw it last time, but really good. And these are things that if you're a SQL Server DBA, these are things we need to know because it'll help us when not if but when we get into slow queries and sooner or later it will happen. And it doesn't have to be a create table statement in a stored procedure. It could be something that is in the execution plan, a spill to TempDB, whatever. And it's the same effect basically because these are also objects in TempDB.
Yeah, thanks for the opportunity. Thank you so much.
I'm glad you, I mean, for you it must be like, is it morning?
It's 7 in the morning now. Yeah, I started off at 5:45 in the morning.
Oh, yeah.
I'm an early riser. I wake up at 5. So
I mean, I often wake up early as well, but I'm not ready to do a presentation in the morning anyway. It's a different thing.
Yeah, I don't blame you. I mean, I had my laptop and everything set up last night, like, the Perform, SSMS, everything set up. And then I woke up this morning and then I got my kids ready and everything like, hey, here's, things, just watch TV or, do this, do that. I gave them everything to